Today we're going to go through a quick build on a 100 amp hour 12 volt lithium iron phosphate battery. This is going to be very similar to a Battleborn battery, a Roku or Lion Energy that you can go purchase for anywhere from probably $600 to $1,000. This is going to be the DIY version. You can use a little toolbox to put it in, and it's going to be very cost effective. So here we go. First step when you get some of these cells in the mail was I needed to put these screws in the top so that you can get access to all of the terminals, and you want to check the voltages on them. So these will have been resting for a while because they had to be shipped to you, probably from China. So we're just going to set up our voltmeter here and just run all the way down these cells, and I've got the positive and negative mixed up there. Let's go ahead and get that right. So we're at 335, 335, 335, 335. These are all perfectly in line voltage wise, but what you want to do is, if they're not, you want to get these balanced. So what you do is you balance them with each other. So grab your bus bars. First of all, you want to make sure that all of yours are sitting in the same polarity. So you can see here, this has the copper color and this has just the nickel color. And you can see where the barcode is here. You can also see when you did the voltage test that when I had the way that I had the probes, they all showed up as the same polarity. And you can see here, they're all the same polarity. They're all facing the same way, right? When you're putting them in series, they're not gonna look like that. What we're gonna do is connect all four of these terminals together and then all four of the back terminals together. And that will allow them to balance to themselves. So just stick the bus bars up there. Loosely tighten these nuts down. I don't wrench them down. You just need an electrical connection. We're not going to be pushing 100 amps through these things yet. You're also going to be very careful because you don't want to short anything out. So make sure that you mess with a bus bar at a time and don't let a positive and negative touch each other. All right, so now once you've got all those on, you'll notice that I only had 4 bus bars. So now I've got 2 banks of 2 batteries here, right? So what I'm going to do, you don't need a whole lot of capacity for balancing these out. So I'm just going to grab some of these little jumper wires here. These are really handy. I just grabbed these off Amazon. I've got a link down there if you want to grab a few of them. So we're going to connect these 2 together, and then on the back side we're going to connect these 2 together.
Because the discharge voltage curve is so flat on these lithium iron phosphate cells, really once you get everything connected in parallel here, you need to connect a charger to it and charge up all 4 cells to 3.6 volts. That'll make sure these are top balanced, and it'll reduce the load on your BMS once you connect everything in series.
All right, so now that you've got your batteries, your cells balancing, the next step is going to be preparing your BMS. So what I've got here is this BMS from Aliexpress. This is a 120 amp BMS, 12 volt. So this is set up for 4 in series of a lithium iron phosphate, and that is different than lithium ion. You have a different voltage range. This one does have a temperature sensor, so we'll be going through the settings to make sure that it does a low temperature cutoff so that you're not charging your iron phosphate cells when they're too cold. And we should be able to do a high temperature so that we don't charge or discharge when the battery's too hot. Now, what I did here is this came with bare wire. So you've got these 3 10 gauge wires coming off here on each side, which is perfect for a 120 amp BMS. That's what, about 40 amps a piece, and they're nice short runs. I have pushed these into some 6 gauge crimp ring connectors. I went ahead and soldered them in, being 3 wires seemed like a safe way to do it. Probably would have been fit a little bit better in, say, a 4 gauge, but 6 gauge worked for me today. The way I did that was I took my 140 watt Weller 8200 classic soldering iron here, made sure that my tips were nice and tight to make sure I was getting all the heat through, and then just apply full power, so 140 watts, onto the ring terminal itself, and get this nice and hot, and then get some solder down into the wires themselves, and make sure that all 3 of those wires get solder and end up soldering themselves to the ring terminal so that you've got your full connectivity there. And then what I'm going to do when I'm done building this is I'll pull a good 60, 80, 100 amp load on this get an infrared camera out and make sure that I don't have any hot spots, indicating that I didn't get one of the wires connected, or maybe one of these wires will be showing colder than the others, indicating that it's not making as good of connectivity. So now that you've got your B- and your P- off of your BMS, because what this is going to do is interrupt power on the negative side of the battery. There is a row of MOSFETs on the top and the bottom here, and that's what this metal plate is for, is as a heat sink for these MOSFETs. And what that does is it turns on and off the power flow through the negative end of your battery. And that's to protect you for all of the things that the BMS does. So if any one cell goes above or below the voltage that it's supposed to be, if the battery is too hot, if the battery is too cold, it will turn it off. I want a BMS so that I don't have to worry about what temperature the battery is, and I don't need to worry about checking the voltage on it constantly, especially the individual cells. Who wants to do that? Let the BMS worry about it, and we will go on with our lives. Now, there are two connectors here on the back of the BMS. So this one here is going to be our balance leads. So you'll see that it has a black, 3 whites, and a red. So your black is going to go to the main negative of the battery. And then as you go across, you'll do white on the positive of that cell, and then white on the positive of the next cell, white on the positive of the third cell, and then this red will go on the positive of the fourth cell, and it will also be the main positive of the entire battery. So that will give you 5 wires that will go from the BMS leads, the sense leads, onto the battery. Then the other connector is going to be for our Bluetooth module, which this should be optional, but I want to make sure that I get this plugged in and configure the BMS. And then after it's configured, I can probably go ahead and pull this out if I want to, but I'm sure it's got some monitoring capabilities if you want to check on the status of the BMS. Because the beautiful thing about running the power through a BMS is it can tell you what kind of current is running through the BMS. And that would be, more accurate than, say, a voltage gauge if it's able to do capacity monitoring, because you can measure how much current actually came out of it as opposed to just the voltage reading of an iron phosphate battery. If you've ever watched one of these discharge, from the very top, they sit at about 3.65 volts is what you can charge these cells up to, and you'll discharge them and they'll get down to like 3.5, 3.4 volts, and a lot of their capacity is right around that voltage. So somewhere around 13 volts, the battery's going to sit during discharge, and it'll sit there a really long time, and then it'll just kind of drop off after that into a lower voltage, but you don't have a lot of capacity at that point. So it's nice to have a current sensor to see how much current you're pulling out to know how long your batteries are going to last instead of just a voltage readout. Since I've already got my main terminals connected, what I'm going to do is show you how I'm going to do my sense wires, because I'm going to need to connect my sense wires here onto the terminals of the battery. And I will show you how I do that, changing it from just the little end here that's soldered into something that can go onto here for very little money. Right, so the tool we're going to need for this is going to be these strippers. Grab them down, link below, they're just sitting up there on Amazon. And so what we're going to do is we're going to go ahead and strip off a fair bit of wire from each of these sense leads so that we can make our own little ring terminal that will work for our cell. I've used this on a couple of my batteries recently, and it's a little bit time consuming. It's not too bad when you've got a 4S battery and you've got a 14S battery and you're trying to do a sense lead for each. That can take a while. So I'm stripping off about an inch or so from each of these leads. And these leads are going to be plenty long enough, so I'm not worried about losing some of their length. Alright, so now that you've got some nice long leads, what we're going to do here is some soldering tricks. I'm going to go ahead and turn on my smaller soldering iron. It should be a little easier to use for this scenario. This is another Amazon find. If you need a digital soldering iron, we're going to take each of these, twist them up a tad, and then just turn them over on themselves, making a nice little loop. And you can go ahead and test fit this loop onto your battery terminals, making sure that it's big enough. And then what I'm going to do is just solder that in place. So if we just stick this in here, grab some of our 6040 solder here, lead free because we like to keep ourselves healthy around here. And I do like to go ahead and give the rest of the wire a little bit of solder. It kind of makes it a little more rigid, since you're going to be clamping this down with the bolt. That's all there is to it right there. Now you've got homemade ring terminal that you can stick on your battery. So let's just do this to the other 4 wires here real quick, and we'll get moving. Alright, so now we have 5 ring terminals ready to go on to the battery. So BMS sense leads to determine what the battery cell voltages are, and we've got our large ring terminals ready to go. Alright, so now we just wait for this to get done balancing out, and we will move on to putting it in series, 4 in series, and get going. So here we are. We're going to find out if the voltage of these cells has balanced out. Now, what we're going to do is go ahead and pull off any jumper wires and any of your bus bars that you had connected, and let all the batteries sit by themselves. Make sure that you pull 1 bus bar off at a time and set it aside. What I've found is that if you leave one loose sitting around, it's much more likely to short onto something else. You might think 3.7 volts isn't that bad, but it's a lot of amps. It's a lot of amps. So these batteries can discharge quick. Alright, so now that you have all of your connectors off of here and they're balanced, which is going to make things easier on our BMS when it gets connected, it will passively balance as the cells get to the higher voltage when you're charging, and will keep everything charged up, or in balance, keep everything in balance. But we give it a good head start. Now that everything is all the same voltage, and we can verify that with our handy multimeter. Alright, so first cell, 3353, 3353, 3354, 3353. So those are perfectly in balance at the moment, at least voltage wise. So we will set that aside. Now what we want to do is go ahead and set this up in our 4 in series configuration that we want. So all we're going to do is take every other cell here and flop it around like that. Then what we'll do is determine that this is going to be our main positive and this will be our main negative. So we will stick bus bar here, here, and here. So that allows the power to flow right down the bank, and we will get our 12.8 volt nominal. Alright, so first thing is I need to get these little doodads tightened up. So I need to get my Allen wrench out. I wonder if this happens to be the right size. Probably not. Nope. Let's see if I can find an Allen wrench. I'm just getting these snug so that they make nice and good connectivity. Though the bus bar is really going to make connectivity straight down to the flat piece in here. Your nuts are really just to hold the ring terminal down. Power is not necessarily supposed to flow through the nut itself. I'm sure it does. It's not its primary responsibility though. Alright, so now that we got those snugged up, we need to get our sense wires out. And I'm going to go ahead and pull these off because they're for demonstration purposes. And what we're going to do is look at our sense wires. Now this is going to be pack positive, this is pack negative. So we are going to need to connect. Notice that I do not have it connected to BMS right now. So our pack negative is going right here. We have a C minus and a B minus. Our B minus is what's going to go to the battery right up in here. So let's get that connected along with our minus sense wire. And grab a washer, keep everything in line here. Just throw BMS right there. Throw our sense wire on. Let's do our sense wire the other direction since our connections are going to be over there. Throw a washer on top. Add a nut. Then we're going to grab our 10mm socket. See, notice how this wire just sticks out the side of the battery. It's not very low profile of it. Now, that could go either way. Really, you don't want the BMS to be sitting right against the battery, because this BMS is going to get warm, maybe even hot. So actually, having it out like that, maybe having some foam in between could be nice, because that will keep things insulated between the battery and the BMS. So I like that. Let's do that. The question is how this battery is going to fit in its end case. And I don't have a box for it yet. But we'll go ahead and stick it this way, and I mean you can always stick it, you know, back around this way if you need it up along the front of the battery, which actually would fit really nicely there. Let's do that. I like that. I like the way that looks. So let's get this tightened into place. And then what I did too, I went ahead and grabbed my 1/4 inch torque wrench. This guy will go up to 200 inch-pounds, and while I don't have actual specs for these cells, what I was reading was like 10 to 20 Newton meters for torque. So I'm going to go ahead and set this up to about 170 inch-pounds, which would be somewhere around 20 Newton meters. And just make sure you're careful when you're working with metal tools on a battery. I'm not sure. This is a lot of torque. Let's go down to say 140. Let's see if we're at 140. No? Let's see where we're at. This is 95. 95. Let's go for there. Alright, so now I got a BMS awkwardly hanging off the side here. That is nice and tight on there. Sense wire is nice and tight. So now, on our sense leads, we have connected our black wire. We're going to go for the very next white wire. That is going to go right here. What I'm going to do is put our bus bar on first, and then we will grab a washer and throw a nut on there. And then this end is not going to have a sense wire, just a washer and a nut, since it is a negative terminal. Let's go ahead and get these tightened up. One bus bar down. Alright, so now this one's going to be a positive terminal. So let's stick our bus bar on, and we'll go back to our BMS sense wire harness, grab our number 3 wire, stick that right there, washer on top, and a nut. Grab our last white wire. Alright, so now just the one wire left here on the end. Now what are we going to do for that? What we're going to use here is some of this 6-gauge welding wire. Now here I've already crimped this 6-gauge lug on here. This is what I used. I'd like to upgrade these to the hydraulic crimps. But this is the setting that I used on these from Amazon, and I went ahead and crimped it twice and it worked okay. So I'm going to run the positive wire here, and that will go over to the side of the battery, so I can give myself a wee bit of length. I think for now I'll probably just bolt this on here, and then we will get the length once we know where our terminal is going to be. So now this is the part where you do verification. this is your BMS sense lead, right? And so if you think through this, this is your pack negative. So if you measure pack negative to the first white wire, you should have about 3.5 volts. If you measure black to red, you should get 12, 13 volts. And then the other thing you should do is read, so black to first white, that should give you 3.3. Black to second white, that should give you 6.6. Black to third white should give you 9, 10 volts, 11 volts. And then the last one would give you that full pack voltage. So let's go through that and make sure that our BMS leads are correct before we plug it into the BMS and blow it if we got it wrong. All right, here's our 3.3, 6.7, 10 volts, and 13.4 volts. It's exactly what we expected. Now, last verification, I did this based off of wire color, right? We need to look at the BMS. So if we look at the BMS, this has a BC0 through BC4. So that would tell me that 0 would be black. Now if we look at where it's going to plug in, 0 is black. So that looks correct. So before we do that, I want to know, do we have voltage across the BMS? Because we shouldn't, right? At least not a considerable amount. So we do have 12.6 volts, but you'll notice that that's less than pack voltage. Pack voltage is 13.4. So there's a little bit of a leakage that gets through there, but it's not enough to run anything. Now let's go ahead and plug the BMS in and see what happens. Now, let's see if it turned on. So, pack voltage, 13.4. BMS voltage, 13.4. So it turned on. It likes the cells. Now, let's see if the Bluetooth works. So we're going to take our Bluetooth cable here, plug it in. It did blink blue there for a second. Alright, so here we are doing a load test on these iron phosphate cells. I just wanted to show you guys what we got. So here in the app, we're sitting at about 44% capacity. We're pulling 106 amps, about 1300 watts. And then if we want to compare that to my clamp meter, where we're at 106 amps, so that lines up pretty well. Now this shunt here is on this screen, and it's showing 109.5, so I think it's a little bit off, even though I've tried to calibrate it. That seems to read a little bit high. So the load is my heat gun here running at full blast, and things are working pretty well. So let me show you some infrared camera footage to see if things are getting hot anywhere. Alright, so we got here is our BMS, which is actually not terribly hot. Alright, so we're coming to the end here. We have an estimated 11.5 amp hours out of this battery that are remaining. Our voltages are down to about 3.1 per cell. And if we go check the config, let's see where our alarm is set. So our cell under voltage is set to 2.5 volts. So that's actually going to be a ways before it gets to that point. But these batteries will drop off quickly after 3 volts. Have this set to a full charge voltage of 3650, so that's 3.65 volts, and an end of 3 volts, which explains why we're reaching the very end here. So we're at 10% capacity at 9.5 amp hours left, just under 3.1 volts apiece. So let's go ahead and watch this to the end here. So here we are reaching the very end of this discharge cycle. We're just under 3.1 volts per cell. Our app is showing 6% remaining. I believe it's going to show 0% when we hit 3 volts based on the settings. And then let me show you, so this is showing 5.7 amp hours left out of 100 amp hours. And this one's showing that we've got about 4.7 left. So they're very close to each other. It looks like we're gonna get a full 100 amp hours into this, maybe a little more than 100 amp hours, which would indicate these are actually brand new cells. Okay, so here we are. We're at 3 volts per cell, so we've hit 11.99 volts per pack. This BMS is gonna shut off till 2.5, and I might go ahead and bring that up to 3 later. But since I'm watching it, I'm gonna go ahead and shut it off now. You can see the voltages are starting to drop faster and faster because there's not a lot of capacity below that 3 volts anyway. But look at this. We got 104 amp hours out of this pack, which does indicate that it's a brand new iron phosphate cell, because apparently the first time or two that it's cycled, it gets more than its rated capacity. Let's shut this stuff off. We can see the cells starting to auto recover. We're back up to 12.3 volts. That was a very good test. Like, the BMS did not get overly hot. It's warm, but it's certainly, I mean, perfectly comfortable to grab and touch. And that was running at about 105, 110 amps there at the end. 110 amps is what it was running at. And it's rated for 120. The 10 gauge wires do get pretty warm. But it was like, what, 100, 105 degrees on the thermal camera. So that wasn't too bad. I consider that acceptable. Wasn't quite running it at the full rated amperage. But a lot of people complain that these Chinese BMSs, you can't run them at the full rated. But if we're running this thing at 110 amps and it didn't even hiccup, I feel like that's really impressive. I liked the BMS. I didn't cheap out on the BMS in the sense that this was a $80 or $90 BMS from Aliexpress. So the internal shunt compared to my external shunt actually ended up being really close to each other in how much capacity there was in the battery. So I was happy with that. Let's go ahead and set this all up for charging now, and we'll see how much of a charge it takes. All right, so now we're gonna set this up for charging. Let me show you what we've got here. Right here, we've got this big fat cable. This is bringing in 1,600 watts worth of solar on 2 sets of panels. These are 400 watt panels. So basically I've got 2 positive wires here. Each of these is an 800 watt array. I have both of these running into this charge controller, so it has an available 1,600 watts. Now, it's only a 60 amp controller, so we should see this maxed out at 60 amps out to the battery. Now 60 amps at 12 volts is what, about 720 watts. So we should be charging at about 720 watts. We've got our positive wire running here to the positive terminal of the battery. And we've got our negative wire running here to the input of the shunt. From the output of the shunt, we have running here, we're just using this as a handy terminal, and then over to the BMS, through the BMS to the negative terminal of the BMS. So the internal shunt on the BMS will be able to measure how much current's coming through, and we'll also be able to see how much on here, and this one's a little optimistic, so it should be showing a little bit higher. All right, so now that that's all set up, we also have a cold glass of water here. I'll probably add some ice to this, and we'll be able to test the temperature sensor to make sure that low temperature cutoff works. So it looks like we're charging at about 48 amps. Our cell delta is only 0.007 volts, which is awesome. No balancing needed at that voltage delta. And you'll see here there's a temperature sensor 1. So let's see if this temperature sensor works. All right, so I'm gonna take our sensor here, drop it into our cold glass of water, and let's see what it reads. Not cold enough. That's what it says. Let's get some colder water. Okay, so now that we've got some ice water, we will stick our temperature probe into the liquid here. 2 Celsius, 1.2. Look at that, charge under temperature protection. All right, so what does that do? We've got 0 watts coming in. Let's see what our charge controller shows. For whatever reason, it's still pushing some wattage. Who knows to where? All right, so then let's watch this recover. We pull it out. That was really quick. Back in. There we go. That's what we needed, and this is why we paid a lot for this BMS, right? Not all of them have under temperature protection, but you need that for lithium iron phosphate. All right, let's let this puppy charge up. All right, so what we're gonna do now is get this into a box. I've got this toolbox from Walmart, $7 special, and it should fit the cells nicely, and it'll give me something easy to drill through to put our terminals on, which are gonna be these 3/8 screw lugs. It should provide nice firm connection for any inverters or whatnot. This BMS is gonna be rated for 120 amps, so I've got to think about that for these. These have gotta be for 120 amps. These are probably overkill. These will work nicely. So what I'm thinking is here on the side, we put one on each side here. So positive and negative here. And then from the inside, we will have the battery sitting vertical in here, terminals up top, connectors on the top of the battery, the BMS sitting on top of the battery about the middle, and then down here at the bottom we will have the terminals out to the outside of the battery. We won't have any wires connected up on the lid, that way it can be opened without a problem in case I need to maintain the battery in some way or fashion. Not that I expect it to die, but just in case. All right, so let's get some drills holed and these terminals put in. All right, so we've got our 3/8 drill bit here, and I'm going to try get this centered up so that it sits nicely. So I'm just gonna go ahead and drill right there. That didn't take much. Let me see if I can get one on the other side here about the right height. There we have it. I'm gonna get these guys out. Let's see, let me pull this end off. Washers. So then I'll be able to feed this through the inside. Actually, I guess I could do a larger hole than 3/8, that way it would fit this plastic piece. With this being a plastic box, I don't actually need insulators. So I wonder if I should just do it like this without insulators. You have to make sure you don't leave too much thread exposed, because this will bottom out when you go to try to screw it on. Yeah, something like that should work out nicely. So now I'm just going to thread in the ones on the inside here. Alright, so here's what I've done. We've got on the front, this black piece holds that nut in place so that you can turn it. And then on here, I've got this nut here, and those need to be super tight so that when you go and unscrew this one, it doesn't unscrew the connection that we've got going on here. So I've grabbed my 17mm wrench. We're going to get this tightened up nice and snug. Now I can thread that one on. What we've got here is the two washers for this end. Whatever terminal goes on there. And then on the inside, I'll have a nut for getting my battery connected to the inside end of this terminal. So that's good to go. Alright, so let's get our positive end in there. Alright, now we're ready to stick some cells in there. So here's something that's neat, guys. As we're charging back up, this BMS has figured out that my actual amp hour capacity is something like 106. So it's counting up to see how many amps have gone in, and it's counting up to 106. So now we'll see how many actually get into the battery. Alright, so what I'm going to do now, which is something I probably should have done at the beginning before I had a bunch of wires in here, is go ahead and get this taped up so it's a little easier to handle as I'm moving it from the table and into the box, and to just keep it together. This isn't supposed to be a super rigid...
Something else you should do is use some fish paper between each of the cells, so 3 pieces, just to make sure they don't rub on each other. You'll see this blue insulation shrink wrap stuff on the outside of each of the cells. If that rubs through and you get a short between the batteries, that can cause them to self-discharge.
And one thing I do not want to do is tape the BMS to the batteries directly, because I don't want that heat transferred from the BMS to the batteries. Alright. That'll make the pack a little easier to handle. BMS is going to end up sitting like that when it's in the case, and I'll get a piece of foam to sit here to insulate it from the batteries. You'll see that in just a minute. So next step, let's get the battery into the box. Now let's test fit this battery, which I believe is gonna fit just right here. Yes, sir. Fits pretty nicely. So this is our negative lead, which is gonna come right down to there. So that'll fit all right. And then our positive lead, we'll need to run our wire from our positive terminal right here over to our positive lug, which is going to be right down in here. So that should fit nicely. And even if we raise this up a little bit, there's a cavity back in the lid here, which will enable it to be visible. So the other thing I wanted to do is make sure that this is how we can have this in here. And I need to get some wires in place. So one is to organize these BMS wires so they look nice, and I've got some small zip ties for that. And then we can go ahead and bolt things in place. So let me pull it out and get these BMS sense wires where they're supposed to go. If you want to understand, it's reasonable to put a temperature sensor on like a terminal, but I wouldn't want to put this under the washer because that would just crush it. So what I might do, if I took one of these off and had some heat shrink that was large enough, I could stick it under the heat shrink and shrink it back on. Let me see if I've got some heat shrink that's big enough for that. This might do the trick. Let's get this unbolted real quick and see if we can do that. Alright, so I don't have any heat shrink down on the tabs, that's good. Now we'll stick a temperature sensor up in there between the two heat shrinks. So there we have it for the inside of the battery. So this should shut. Should. It's a little tight the way that I've pressed the box out. I want to give the battery a little bit of compressive strength. So it's heavy, but it's manageable with one hand. So let's get this hooked back up to my charger and get going again. All right, here we go. Let's flip the breaker on, get some charging. It's getting late in the day. We've only got 250 watts coming off the panels. Let's see if we can get this topped up the rest of the way. Oh, that's unfortunate. It restarted my counter. I guess if you leave the battery on all the time, the counter might stay the same. One of our last steps here is going to put a vent hole in. Each of these batteries is vented just in case something goes wrong. And the last thing you need is to have a bomb on your hands. So I'm just going to put a little hole right here, just in case. There we go. Now I have a vent. And there you have it. This is our Battleborn killer. So Battleborn is a 100 amp hour, 12 volt lithium iron phosphate battery, which is a wonderful battery. Comes with a lifetime warranty. And if you have the money to pay for it, you don't have to worry about it. If you don't have the money for that and you want to do a DIY, this is a great way to do it. There's just the 4 cells inside. Battleborns have the cylindrical lithium iron phosphate battery cells. Probably have some advantages. This one is nice and compact, much easier for a DIY. You don't need a spot welder in order to put together this battery. So the cost on this battery, I spent about 200 bucks on the cells. That was from Alibaba. I'll throw the link down below. Now, in order to get a price of $200, I did order 8 cells, not 4, and I asked them to ship via sea, not air. So be prepared that if you want them that cheap to not have to pay for the higher cost air shipping, that it could be 45 days before you get these cells in. So just keep that in mind. That is part of the cost. So the BMS was from Aliexpress. That was $71. That includes the Bluetooth module, so where I can program it and remotely monitor what's going on, how much amperage is going in or out of the battery, and look at my cells to see how healthy the battery is without having to take it apart and get my multimeter out, which is a very handy tool in and of itself. The toolbox was from Walmart. That was $7. I figure about 20 bucks worth of Kapton tape, terminals, wires, solder, that kind of a thing, just supplies that I used on this battery. And that comes out to $310 for a 1.28 kilowatt hour battery pack, which is what the battled ones are also rated for. Now this one we did do a discharge test, and it actually got 106 amp hours out of it, as you saw in this video. Now that's with brand new lithium iron phosphate cells. Usually you expect a larger than rated capacity for the first, I know it's at least the first discharge cycle, so it could just be very well be that that was the first one and they'll get down to 100 amp hours and then start slowly degrading from there. A great thing too is that this is a 120 amp BMS, and I was testing at 106, 110 amps. It was handling it just fine. It's got nice big heat sinks for its MOSFETs, and it was fine. At 120 amps, you could do 1.5 kilowatts out of this. So you could pick a 1.5 kilowatt inverter and drain this battery in like 45 minutes. And the cells are fine. They can go up to a 2C discharge rate, and that would be at 200 amps. We're only doing 120, so the cells can handle that. And the BMS can handle it because it's rated at 120 amps. You do have the low temperature cutoff, which I bought this BMS specifically for that. You could get a less expensive BMS that would be able to handle 120 amps, but usually it's the programmable ones that have the low temperature cutoff, and so you're going to pay a little more for that Bluetooth module, the programmability, to be able to change where your low temperature cutoff is, but you definitely get some advantages with having that module on the BMS. Check it out, go look at the links, see what you think about building your own battery. Also, if you're interested in some more videos, I told you that I ordered 8 cells, not 4. The other 4 were not the same size. So if you're interested in another video, hit the subscribe button, and I'll be uploading one with some 240 amp hour cells that I will be building into a battery pack. That will be a 3 kilowatt hour pack, and it will be even more cost effective than this per kilowatt hour. So stay tuned, and y'all have a great one.